Hi, my name is Jason Harlow. Welcome to my V Office Hour. I'd like to go over my solution for Physics 132H1F Fall 2009 Test 2, version 1. This is question 5, which is based on Knight Physics for Scientists and Engineers, 2nd edition, Chapter 31 on current and resistance, in particular resistance and Ohm's law, as well as Chapter 32 from Knight on fundamentals of circuits, and in particular energy and power, and its definition for power dissipated by a resistor. So first, let's carefully read the question. How much power is lost as heat along the length of a 15-meter long wire in the walls of your house? And in parentheses, the wire is made of solid aluminum, has a diameter of 2.0 millimeters, and carries 12 amps of current. The resistivity of aluminum is 2.8 times 10 to the minus 8 ohm meters. Choices are 4 times 10 to the minus 6 watts, 0.13 watts, 1.6 watts, 4.8 watts, or 19 watts. So just to let you know where we are, in Chapter 31, it talks about resistivity of materials like aluminum. It's listed there in ohms meters. And on page 956, there's an equation 31.23 for resistance as a function of rho L over A. And then if you skip ahead to Chapter 32 on power and energy, there's on page 974, there's equation 3214, which is power dissipated by a resistor as either I times V, or V is the voltage drop across the resistor and I is the current through the resistor, and that can be measured, also written as I squared times R or V squared over R. So that in mind, let's take a look at my solution. Okay, so looking at my solutions, the basic idea is just applying this equation to find resistance of the wire. R equals rho L over A, and then there's several equations for power. Power is I times V, but it's also equal to I squared times R if you combine it with Ohm's law. So that's the basic idea. To find resistance, you should note that it's got, the wire has a diameter of 2 millimeters. That means it has a circular cross-section. So we should find the cross-sectional area as pi r squared, where r is going to be 1 millimeter. So plugging this equation into I squared R for power, and plugging in the numbers, we have 12 amps of current squared times the resistivity rho, which was given, 2.8 times 10 to the minus 8 ohm meters, times the length of the wire, L is 15 meters, and divided by pi r squared. This is 0.001 meter squared. Plugging that all into my calculator, I get 19.2 watts. So actually, it's quite a lot of power is lost by just carrying a normal current of 12 amps through a 15-meter long wire. And the answer is E. Okay, so two main concepts. One is the difference between resistance and resistivity. Resistivity is a property of materials like aluminum or copper. They all have a certain tabled value of resistivity. And resistance is a property of a particular element in a circuit. So, like a wire always has a resistance, or a light bulb has a certain resistance in ohms. The other concept is that of power. Power is current times voltage, meaning current is carrying some charge through a circuit at some rate per second, and the voltage determines how much energy per charge is in that charge. So when you multiply them, you end up with energy per second, which is watts. So if you have a power supply of some voltage, and you're drawing a certain current through that, you can multiply those two things and find out the power. Or if you have a resistor where there's a voltage drop across and there's some current going through it, that must be generating heat. Okay, there must be some all that energy must be going out of the circuit somehow. And again, that's the voltage drop times the current through it. My name is Jason Harlow. and I approve this message.